Hello everyone. In this video, we're going to be solving an interesting exponential equation. We have the square root of 2 plus root 3 to the power x plus the square root of 2 minus root 3 to the power x equals 4, and we're going to be solving for x values. I know to some of you this probably looks obvious, and we'll talk about that later. But let's go ahead and take a look at how we can solve a problem like this. First of all, I want you to notice that these two expressions are conjugates. In other words, expressions like a plus root b and a minus root b are considered conjugates because when you multiply them, you get from difference of two squares something like this. And of course, if a squared minus b is a perfect square, then it's a really nice thing to have because that means you should be able to denest these radicals. So do you think denesting is going to help? Maybe, maybe not. But I can show you how to do that first. And then we can proceed with the general solution, how we can approach problems like this. There's a good reason why this problem is, really nicely solvable. But let's go ahead and take a look at this first. How would you simplify a radical like this? And notice that we have a radical inside another radical. So that's what we mean by denesting, right? In other words, if you're able to write this as something like a plus root b, that means you denested the expression. Of course, a and b are rational numbers. Okay? So to be able to do that, we can actually use a well-known trick, which is multiply this expression by root 2 and divide by root 2. And I'll show you why multiplying by root 2 is a good thing. This basically means you're multiplying inside the radical. So like this here, this number is multiplied by 2. So that gives you under the radical 4 plus 2 root 3. And of course, that has to be divided by root 2, but that can be taken care of easily by rationalizing the denominator. Now, what does this expression look like? If you're not familiar with these algebraically, you should definitely know them. This is actually the square of something, which I'll show you now. If you go ahead and take this and kind of break it down like 3 plus 2 root 3 plus 1, and then write it as the square root of 3 squared plus 2 times the square root of 3 times 1 plus 1 squared, you'll soon realize that this is indeed the root 3 plus 1 quantity squared. In other words, this is a perfect square, the square of a radical. And of course, by the same token, this will also be a perfect square. So maybe we can just simplify it that way. This becomes root 3 plus 1 after taking the square root divided by this. Now, to rationalize the denominator, we multiply and divide by root 2 and then use the distributive property. That's root 6 plus root 2 divided by just 2, which is a good thing, right? Now, what happens if we plug this in? Let's go ahead and give it a try. So we replace our radical with this and then just raise it to the power x. And of course, the other one is just going to be the conjugate. So you just need a minus sign, that's it. You don't have to do that work twice. And now this is what we have. Now, do you think this is better than the original problem? Probably, a tiny bit maybe. But we still have to deal with some complications, right? So from this point on, what would you do? Let us know in the comment section because I'm going to leave it open and then continue with my second method. And we could probably call this the first method, even though it's incomplete. I hope you'll forgive me for that. Okay, let's go ahead and proceed with the second method, which is really cool. Okay, so we have this and raise it to the power x. And then we have the conjugate. By the way, I keep saying the conjugate, but these two are conjugates, right? Their square roots are also conjugates. Their squares, cubes, any power of them are also conjugates for a good reason. I'll show you why. Now, one thing to keep in mind here is that one thing that makes this problem kind of solvable is the fact that if you call this a and if you call this b, a times b is going to be 2 plus root 3 multiplied by 2 minus root 3. And that's equal to from difference of two squares 1. You see why it's happening? Now this is a good thing because it means one of them is the reciprocal of the other. Beautiful, right? So we can safely say, okay, b can be written as 1 over a. That's a good thing. In other words, we mean to say the square root of, and of course square root can be included in this because the square root of the reciprocal will be the reciprocal of the square root, something like that. Okay, hopefully you get the idea. Because the product of these two things is 1, of course, the product of their square roots will also be 1. Now, this is a really good thing. You know why? Because if you had like two random things, let's say you had this, and I'm just going to change the problem a little bit, like a tiny bit, okay? And this is equal to 4, let's say, or some other number, this would be very problematic because there's no relationship between these two things, as far as I know, right? But in this case, they're very much connected, and to make things better, they're reciprocals. So what does that mean? Let's go ahead and replace the second one with the reciprocal of the first one. So in other words, we're going to write this like that. And then the second expression, we're just going to write it as 1 over this. Okay? And of course, that's going to give us something interesting because what we can do now is raise this fraction to the power x, which means it's just going to be 1 to the power x, which is 1, divided by this, which is a really cool and at the same time crucial step. Okay, you really need to understand how things work, what are the dynamics here, because you need to know it. I mean, you don't need a reason, right? So here is the fun part. We got the same thing twice. So if you call this y, and don't ask why, you're going to get something like this. Y plus 1 over y equals 4. And guess what? This is a quadratic equation. That's the beauty of substitution and doing these manipulations, because notice that we have a crazy looking exponential equation. Exponential equations are usually easy to solve, but only when the bases are equal, or you can turn one base to the other, or you can find a common base, so on and so forth, right? So there needs to be something, a pattern that makes it easier. In this case, it is the reciprocal relationship. Make sense? Not something like a common base. But anyways, so let's go ahead and multiply by y, and then put the 4y on the left-hand side and solve this quadratic equation. This quadratic equation is critical because it's going to give us an idea about the value of x, right? So it's going to be from quadratic formula, negative b plus minus the square root of b squared minus 4ac, which is minus 4, divided by 2. That's a 12. The square root of 12 is 2 root 3. You should know that. 4 plus minus 2 root 3, because 12 can be written as 4 times 3, and then you can split them up. Okay? But you should know it by heart, so it's much better. Division by 2 gives us 2 plus minus root 3. Awesome. Does that look familiar? It should. Now, let's go back to y, and y is the square root of 2 plus root 3. By the way, does y include the x? Yes, it does. So you have to take the whole thing and set it equal to y. So like this, okay? Not the inside, but the whole thing. What would happen if we use the inside? Then we would probably have to do more substitution, which is more work, unnecessary. And now this is y, and it's equal to 2 plus minus root 3. But I'll take one at a time. Let's go with the 2 plus root 3 first. What do you notice? Like, how do you get 2 plus root 3 from the square root of 2 plus root 3? The inverse of the square root. You have to square it. So from here, x equals 2. Now you might be wondering what happens with the other value, right? So now we're going to set it equal to 2 minus root 3. But you just got to remember, at this very point, that 2 minus root 3 was the reciprocal of 2 plus root 3. Therefore, we can now write this equation as follows. 1 over 2 plus root 3 can be written as what? 2 plus root 3 to the power. By the way, I probably messed up somewhere. Did I? No, I didn't. Okay, never mind. I thought I did, but I didn't. Okay. We can write this as to the power negative 1, right? That's what the reciprocal means. Great. But it's always a good idea to check your work, right? In case you made a mistake. And I make a lot of mistakes, and I don't cut those parts. So you kind of get to see my thought process. And some people don't like it, but most people, I think, like it, right? If you like it, give me a like down below. Anyways, so What are we going to do here? Well, we kind of have the basis, but this is a radical, right? So you can think of it in different ways. Well, first of all, this is 2 plus root 3 to the power 1/2 multiplied by x. It's just going to be half of x. You got that, hopefully. And now we can go ahead and compare them because now they have the same base. You see, you need the same base. Be very careful. Don't go directly for the solution. Now we can safely say that the exponents are equal. From here, x equals -2. And this is expected because remember the first solution was x equals 2. And these two things are reciprocal. So obviously the negative power gives us that power. Make sense? Okay, so there seems to be two solutions, x equals 2 and x equals -2. Is that are those the only solution? How can you tell? That's a really good question, right? But it's a quadratic, come on, so there can't be any other solutions. But now let's go back to the original problem and look at it from a different angle, slightly different angle, right? Now, notice that 4 is 2 plus 2. And the only way to get 2 plus 2 from here is by, oops, by the way, I just made the, what's it called? The square roots disappear, hocus pocus, math magic. Yeah, there should be square roots. So the only way to get a 4 is from 2 plus 2. And that 2 needs to come out, and that 2 needs to come out. In other words, if x equals 2, we get rid of the radicals, and we get 2 plus 2. Make sense? I hope that makes sense. Sometimes I confuse people. Some people call my writing sloppy, my work. I try to take my time, but then when you take your time, it's like, why do you take 10 minutes for a video? You know, you can never please everybody. So that's something that I learned during the process. But anyways, when you do this, you're basically going to be ending up with 2 plus root 3 and 2 minus root 3, which gives you 4 at the end. And that's what we're trying to get. So x needs to be 2 in order for this to work. Quick observation. Now, what would happen if we didn't have a 4 but a larger number? We'd probably try for x equals 3 or x equals 4. But this is a good question for you. Is this expression when x is an integer, and I could probably use n, but I like to use x as well. Now, is this always an integer, right? When x is an integer, is this always going to be integer? Something to think about and try to explain why or why not. And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe. Take care. Don't forget to check out aplusbi, which is a channel that I have, one of my channels, that focuses on complex numbers. If you like complex numbers, check it out. If you don't like complex numbers, maybe you'll start liking them. So give it a chance. I also have a shorts channel, which I publish once a week. Sorry about that. I'm pretty busy these days, and I'm also changing the schedule slightly bit, which is I'm replacing one of the aplusbi videos with SyberMath videos. And there's a good reason behind it, but I'm not going to tell you what it is. You'll probably guess why. Anyways, until next time, bye-bye.